And next, we're joined by Hiro Yaginuma, who's going to talk to us about our favorite interstellar object, 3I, and how we should go there.
Hi, can everyone hear me? Hi, I'm Hiro Yaginuma. I'm a senior undergrad student at Michigan State University, and today I'm going to talk about the discovery and initial characterization of the third interstellar object, the Atlas, and the feasibility of the spacecraft flyby. So, 3 Atlas was discovered on July 1st in this year by Larry Deneau, an observation from the Atlas survey. And this is a third interstellar object, and its study gave us rare chance to learn how planet form in other system, and also compare with that and with our solar system, what happened in our solar system. And this is the discovered images taken by Atlas Chile, and you can see 3 Atlas is clearly moving against the background, and this is the time span is about 1 hour. And this is, oh, sorry. I should be some animation, but like this is there's Tessa Franke, who's the first year PhD student at Michigan State University, made some animation of solar observation on July 9th and 10th, which is on archive. So if you want to see the animation, you can check. And here's some orbit plot. From center, there's the Earth, Mars, and Jupiter, and I gave 3 Atlas in the black color. And you can see 3 Atlas has a strongly hyperbolic orbit, and this confirms this is an interstellar object. And I had some markers, which is 3 Atlas will have a close approach to Mars in early October, which is actually this coming 5 days, and perihelion at the end of October. And this red marker is where the closest approach to the Mars happened, and blue marker is the position of the perihelion happened. And you can notice there's one more blue dot, a blue marker on Earth orbit. This is the position of the Earth where at the perihelion. Sorry. And this is some light curves from several telescope, and there's no obvious photometric variability in the light curves of 3 Atlas. However, the stacked image from both CFHT and VLT showed that 3 Atlas is actively outgassing and has cometary tail. So these light curves and these images show 3 Atlas is continuous activity from when we discovered. So I show a lot of ground observation, and I know there's a lot of amazing ground observation done and also still going. But my question is, can we send a spacecraft to 3 Atlas? Because sending the spacecraft and maybe measure some spectra or even the close-up images can change our perspective. So it is valuable. So in this study, I focused feasibility of the spacecraft flyby to 3 Atlas. So first, why don't we launch some spacecraft from Earth? And I simulated that. The graph is showing a launch date and the minimum delta V, and in the color, it's a flight time. The minimum delta V here is required changing velocity to transfer spacecraft to 3 Atlas from Earth. And you can see delta V value is gradually increasing. So when we zoom in to some more potential launch window, and this black dots line is discovery date, and you can see like after discovery date, the minimum delta V value is at that date, and which is 24 kilometers per second. And this delta V value is beyond the capability of current available spacecraft. So this turns out launch something from Earth and then fly by 3 Atlas is difficult. And this is those spacecraft trajectory. If you launch some spacecraft on July 1st, it will fly by on November 15th. And in this black line is showing spacecraft, and purple line is showing 3 Atlas. And since Third Atlas is having closest approach to Mars, I was thinking maybe send some orbiter in around the Mars right now, or like send spacecraft from Mars. And this is the same plot with we had an Earth launch date, minimum delta V, and flight time in the color. And you can see delta V value are small at the beginning of this year and increases after that. So if you find this interstellar object way before, it would be more like feasible to do something. And same thing when we zoomed in from July 1st. July 1st is the same, having minimum delta V value, which is 4 kilometers per second. This is much smaller than what we had in Earth. And also, delta V value is less than 10 kilometers per second by September. So this tells us spacecraft flyby would have been feasible if we send a spacecraft from Mars before September. And this is the same trajectory plot. Black is showing spacecraft. Purple is Three Atlas, and we added Mars in orange. And you can see there's since it's a short time, July 1st to October 3rd, spacecraft trajectory is short. And also it will fly by on October 3rd, which is when the closest approaches happen. And we also derived the delta V for different Mars departure and arrival date. We gave x-axis in departure date, y-axis in arrival date, and color in delta V. And you can see all the dark color is around the 2025 October, which is because Three Atlas is having a closest approach in October. So this tells us if interstellar object is getting close approach to some planets, the closest approach time is the best time to send a spacecraft. And we can expect the same pattern of minimum delta V for future interstellar object. So what I want to say is it was feasible to send a spacecraft. So having some spacecraft spread around the solar system or repurposing spacecraft around the planet would help us plan a rapid flyby mission in the future. And again, LSST is online now and expect to discover more interstellar object. We hope we discover more interstellar object in this coming few years, and then we can send a spacecraft someday. So here, I want to say one thing is we could use 3 Atlas as real test case to prepare future mission to interstellar object, and maybe still. So keep discovering this object is really important. And someday, hopefully, we can send some spacecraft to interstellar object. And also, finally, I'm applying to graduate school in this fall, and I'm looking forward to collaborate a lot of people in here in the future. Thank you.
Great, thank you. We definitely have time for a question or two. Oh, Henry, back there.
Hello. Hi, Hira. Thanks for the great talk. Henry Shea, Planetary Science Institute. So in your plan for the future, how many spacecraft would you recommend scattering around the solar system for reasonable coverage of the available parameter space?
Thank you. That's a great question. I would say at least some spacecraft in each planet would help, and especially Jupiter. Like having the spacecraft in Jupiter will allow us to having more time since they set up more distance. So having some spacecraft and farther out of Earth. Of course, having more spacecraft on the Earth is helpful, but having spacecraft some farther out, like Jupiter, will help us to fly by these kind of interstellar object.
Hello, this is Bryce Bullen from the Eureka Scientific. So I really enjoyed your talk. Has some really interesting results. From what I understand, the delta infinity of 1i, 2i are a factor of 2 lower than 3i's. And you mentioned that 3i is a very tough one to catch. Would you say that this 3i is a more typical case or less typical case of the overall ISO population? And can we expect other ISOs to be easier to catch in the future?
That's a great question. We really don't know like what speed is the interstellar object is coming, but if there's like if our like a spacecraft technology increase, and also maybe like if it's the interstellar object is just not fast, we may be able to catch or something, or maybe we can like do something of the comet tail. So that's we're hoping to do that. Yes.
Great. All right. Well, we are at time, so thank you again. Let's thank
Thank you.
Hiro and all of our speakers in the session. Thank you very much.